Hi guys, Mishler Math here. Conjecture, postulate, theorem, and proof. These are words we've used before in geometry, and you really need to know what these words mean. Okay, so erase this stuff there. There we go. So look those up. Okay, conjecture, just to give you a rough rundown, a conjecture is something we think is true. And we just look at something, we say, I'll bet you, for example, if I were to put a point right in the center of segment BD and spin this thing around, it seems to me that point A would end up on top of point C, point B end up on top of D, D end up on B, etc. In other words, this thing has rotational symmetry. This thing, by the way, is a parallelogram. So I think that I'm going to make a conjecture that this diagonal of this parallelogram splits the parallelogram into two congruent triangles. Now, if I prove that by writing a proof, then I might have a new theorem. So let's see what happens here. It says I'm given parallelogram ABCD with diagonal BD. Prove triangle ABD is congruent to triangle CDB. Okay? ABD is congruent to CDB. So, let's figure out how we're going to do that. I'm going to write you a two-column proof here, okay? On the left, I'm going to have a statement. And on the right, I'm going to have a reason for that statement, okay? And I am going to get rid of that line because I don't like ugly lines like that. And I'm going to draw a much nicer line. I like those better, don't you? Alright. So, whoops, that's still an ugly line. Let's draw a nicer line over here too, shall we? So the first statement I'm going to make is I'm going to say AB is parallel to CD. Now what does that mean? AB is this line on the top, the segment on the top. CD is the one on the bottom. Okay? So I'm going to say that these two are parallel. How do I know those two are parallel? Well, it seems to me we have a definition of a parallelogram that says opposite sides are parallel. So if the definition of a parallelogram, then the opposite sides are parallel. Well, from that, I can write another thing here. Number 2 is angle 1. I forgot to number the angles. This is angle 1, angle 2, angle 3, angle 4. Okay? So I'm going to say angle 1 is congruent to angle 4. Now, how do I know that? There's angle 1 and there's angle 4. How do I know that those two angles are congruent? Well, because BD is a transversal. It cuts through the two parallel lines AB and CD. And so we learned that in the last chapter, or one of the last chapters. This is the alternate interior angles theorem. You remember that? If we have two parallel lines, the alternate interior angles are congruent. So we know 1 and 4 are congruent. Let's try another one here. Number 3, it says AD is parallel to CB. You say AD is parallel to CD, or BC, CB. And so how do I know that? I'll give you a hint. It's just the same definition up above. Definition of a parallelogram. Okay? And I'm going to try, let's see, this one here. Number 4. Now looking at that, what do you think I'm going to say next? If you said angle 2 and angle 3 are congruent, you're absolutely correct. Angle 2 is congruent to angle 3. And that is the same reason as we had up above. Alternate interior angles theorem. And finally, I've got number 5, not finally because I've got a couple more here to go. Number 5 says BD is congruent to BD. Okay? This line is congruent to itself. Now, we talked about this in class the other day. What reason do I have for that? Well, some of you might remember that's the reflexive property of congruence. And so think about this now. I've got this angle congruent to this angle. I've got this angle congruent to this angle, and I've got this side congruent to itself. So think about this. If I have angle, triangle, B or A, B, D up here, and I have triangle oh Lord, am I ugly at this. I know I don't like ugly lines, but sorry about that. CD or CBD. I've got this congruent to this. I got this angle congruent to this angle. And I got this angle congruent to this angle. So what do you suppose that means? Angle, side, angle. So from that I can write down here, number 6, I can say triangle ABD is congruent to triangle CDB, and the reason is angle, side, angle. And so I'm done with my proof. And that, ladies and gentlemen, is what we're going to be doing through this whole section. We're going to be doing proofs, and we're going to be, statement, reason, and remember that everything has to follow everything else. This is all about logical progression, okay? I had to show that these two are parallel in order to show that these two angles are congruent. I had to show that these two are parallel in order to show that these two angles are congruent. And I had to also show that this line is congruent to itself, or this side is congruent to itself, in order to show that these two triangles are congruent by angle, side, angle. So now I've got all the components here. There's my angle, there's my side or angle, and there's my side, which is in between those two. Okay? So angle, side, angle. And I'm going to stop right there, and we'll talk more about this in class. Thank you so much.